Hello everyone, welcome back to Data Valley. This is Sai Harsha Kondaviti joining you directly from Data Valley's Center of Excellence for AI. In this video, we are going to cover the foundational part of prompt engineering. Everybody is saying you need to learn prompt engineering or you need to master the prompt engineering in order to succeed in AI revolution, right? So, but what exactly is prompt engineering? So, is it a kind of new kind of software engineering? So that no one has experienced it till now, so no one has known it. So some of the developers have been saying or have been mentioning it as new kind of engineering, where we iterate on prompts so that we improve the prompts over the period of time while iterating over the prompts. So every single AI tool out there comes with an LLM, which is nothing but the large language model. And these large language models require specific prompts in order to act in a particular way. For example, if we are using the LLMs for a particular use case, let's say the marketing, to generate the marketing content, and this LLM needs specific prompts in the background, in the sense specific instructions, so that they behave exactly as required, right? So in that case, prompts are nothing but instructions. So improving the prompts over the period of time refers to prompt engineering. For example, if we are developing a product where we follow the software engineering principles, there we develop the product in an iterative approach. Iterative approach refers to developing a product in different parts, or let's say in different sprints. Every sprint has got outputs, specific outputs, and we develop the product in every sprint based on the objectives. Similar to the software engineering principles, while developing the product, we iteratively improve the prompts of the LLMs in such a way that we get the desired output over the period of time. For example, if we turn out to ChatGPT and ask ChatGPT to write a poem or anything, or even to summarize a particular draft or particular document, it summarizes in a specific way where we might get the desired output or even some rubbish output. So in order to get this specific output, what we need to do is we need to give some additional instructions that allows ChatGPT to think beyond its abilities. It got its own abilities, of course, but the thing is, if we give the instructions in a specific way, instructing the ChatGPT to get the things done in a specific way. For example, if I want a poem on a moon or a sun, and I just want the poem to be kind of 4 lines or 6 lines, and with their rhyming, right? If we mention the rhyming as well, it is going to give the rhyming as well within the poem itself. So in that case, what we need to do is we need to instruct the chat GPT to write a poem within 5 to 6 lines on moon or sun, which includes the rhyming as well, right? So in that case, it writes a beautiful poem. So which is different from the instructions that we give, like write a poem, right? Which exactly, like, which is the simple one. Write a poem is a simple one, and when we give additional instructions, it behaves in a different way. So exactly what matters here is, while we are chatting with the chat GPT or giving continuous queries to chat GPT or even Claude, Perplexity, Gemini, whatever it is. Okay. So over the period of time, engineers in the background are iteratively improving the prompts. So while they're improving the prompts, these systems get trained on the data and they learn on how to give outputs to the user's query. So in such a way, prompt engineering helps get the desired outputs or quality outputs from these AI systems, right? So with this, we can understand that prompt engineering is the next skill that everybody is stressing out there to learn and get upskilled, right? So With this view, we have started this prompt engineering foundation series, which helps you ace the foundational mass prompt engineering with all the techniques, with all the methods, with all the the drawbacks in the prompt engineering itself. You can make a note of all these things so that while you attend the AI engineering job roles, you can also be aware of this prompting techniques so that the interviewer or the organization at which you are being interviewed, they'll get impressed because of your skills. Like, you're going to think in a direction where you're going to improve the AI systems. AI systems are going to act in such a way that they're going to mimic the human actions. So, in order for them to perform better exactly as a human, we need to give better prompts so that they improve over the period of time and they can match the human's actions exactly, right? So, we can say prompt engineering is going to be the next important skill that everybody is going to look for in your profile while you apply for data scientist or even NLP engineers, LLM engineers, or even AI engineers as well, right? So prompt engineering has got that importance in the next coming days or coming years. Prompt engineering is going to be some important skill for every job, right? With that, let's understand why prompt engineering matters in AI jobs. Of course, everybody is saying that prompt engineering matters, and prompt engineering is going to be some important skill. But why exactly does it matters? Like the prompt engineering in AI jobs matters because recently Claude engineers, the AI engineers at Anthropic, they have released a video explaining why prompt engineering matters at their jobs. For example, they have been part of this AI engineering team where they have got the role as prompt engineers. So in that case, what they have been doing at Anthropic is nothing but they iteratively improve the prompts so that Claude's response will be optimized and the quality of the Claude response will be enhanced, right? So in such a way, prompt engineers at Anthropic are improving the Claude's instructions so that Claude's thinking capabilities as well as the reasoning capabilities gets improved over the period of time, right? So the reasons for why prompt engineering matters are: prompt engineers are the interface between humans and LLMs. Exactly. Because these AI systems have been developed by the AI engineers, because the algorithms, the models, whatever it is, the deployment part comes into the responsibilities of AI engineers. So these AI engineers are responsible for developing these systems. But prompt engineers are responsible for giving the instructions to the LLMs so that LLMs over the period of time they improve themselves and they give the desired output, right? So while humans interact with LLMs, while LLMs interacts with the humans, LLMs need to understand humans particularly in such a way that humans doesn't get stressed or irritated or even frustrated, because understanding human or humans language is a bit difficult, because we never give proper inputs or we sometimes miss out on important inputs, right? So in that case what we need is there should be someone who translates the human's input into particular format such that machines are going to understand the human's input perfectly, right? So prompt engineers are acting as an interface between the humans and LLMs by converting the humans input into structured format so that LLMs would understand them easily. Sometimes we miss out on the grammatical part, or sometimes we miss out on the vocabulary, sometimes we miss out on the clarity, right? So in order to connect the dots in the information that we provide to these AI systems, prompt engineers write better instructions in the background so that this information will be drafted into a proper text, and then that text would be given to these LLMs. And also, these prompt engineers write better instructions for the LLMs as well to understand the text that it has been given, right? So, and the next reason is prompt engineering is critical for roles at OpenAI, DeepMind, Anthropic, Google Gemini, the Grok, and Perplexity, because we have been watching prompt engineers as an interfaces between humans and LLMs, right? So in that case, every single AI company that is using LLMs, or that is developing or researching on the LLMs, or AI models, AI systems, they definitely need prompt engineers in the background, because humans are going to interact with these AI systems using natural language instructions. In order to optimize the AI systems for understanding the humans better, we need prompt engineers in place, those who work on the actual prompts or the instructions that have been given to these AI systems or the models, right? And third reason is these LLMs are going to power the AI agents, copilots, search engines or the search agents, or even finally they are contributing to this automation. In other terms, we call LLMs have got the feature called autonomy. This is the most excellent feature that LLMs have got, since their evolution. So these LLMs with these thinking capabilities and reasoning capabilities are going to power the AI agents, so-called, we are, everybody is talking about the AI agents in the market. Everybody is building them. Everybody is integrating AI agents into their businesses, right? So in that case, LLMs are going to power these AI agents and the so-called copilots, Microsoft Copilot, GitHub Copilot, VS Code Copilot, right? So copilots are going to act as our teammates when we are working on particular things, right? So it could be a partner in coding, right? It could be a partner in research, it could be a partner at workplace, right? And coming to the search as well, we have got this amazing transformation from normal search engine to AI powered search engines. For example, if you simply go to Google or even Microsoft Edge, when we type for something, the very first information that we get on the top of the search results, earlier it used to be the sponsored list, which means the search engine is going to sponsor some content, which means people pay for ads, right? So in that case, search engines use it to sponsor some content or promote the sponsored content at the top. But these days, with the help of AI search, AI is going to search the information and summarize it from various web sources, websites, and it is going to display it on the top of all the search results. So that's the power of AI search. So where we are experiencing the exact results that matches our queries. So search and information retrieval has has been made easy so that users doesn't get frustrated or irritated while going through different web pages, right? So next level of usage of this prompt engineering is automation. So while LLMs have been powering these AI agents, and AI agents have got execution capabilities, in that case, what we need to do is we need to instruct these AI agents in a better way, where these AI agents understand the instructions and execute the tasks based on the instructions. And those instructions are part of the entire information that we give to these AI agents. So entire information is known as prompt, right? So prompt, when we understand the normal English term prompting is nothing but instructing something to do a particular task, right? So in such a way we can understand prompt engineering is really an important aspect or advancement within the technical AI development, so that we get the desired output from these AI systems when they are instructed in a better way. Instructions, or the better instructions to these AI systems come from engineering of the prompts. So that's where we call it as prompt engineering is going to be next level of software engineering. It is similar to writing a proper code, right? So it is quoted by the Anthropic prompt engineers, right? So with this, let's move into this video of prompt engineering. So the question rises, if I want to become a prompt engineer, what makes a good prompt engineer? Which means, what should I learn or what should I have in terms of skill set to be called as good prompt engineer? So deep understanding of LLM behavior. For example, if LLMs are capable enough of processing this natural language instruction, then how these LLMs are processing natural language instructions in the background is a must important understanding that one should have. So that's why we specify deep understanding of LLM behavior based on the words we give as part of our prompt or the instructions. So we need to understand how these LLMs behave in the background based on the one single, based on the change in the one single word that we give as part of the instructions or the prompts, right? So later, one should be a precise communicator because let's say if I am able to communicate my thoughts in a proper way that one should understand, one could understand, for example, if a beginner or if a kid is able to understand my thoughts or even my words, then we are a good communicator, right? And second thing is, the word precise refers to communicating in a proper way such that we give the entire information in small, let's say, small sentences, or let's say, if somebody is able to understand us when we talk very less, then we are a good communicator, right? Of course, it contradicts on the other hand. If somebody is a good listener, they can understand us better. But the thing is, if you are able to explain things in a less, less words or less sentences, even if we talk less, if you are able to properly put the thoughts or ideas in a proper way, then we can say we are a good communicator, right? So in that case, telling what it has to do or what it has to get it done in a very less instructions or in a very less sentences, then we can say we are a good communicator. For example, let's say talking whatever is required is next level skill, because everybody talks a lot, but the thing is, those who put their views or ideas or opinions in a very less sentences or without talking much, they are referred to precise communicators. If everybody is able to understand, even if we talk less, that means we are able to explain the things even if we talk less, then we can refer ourselves as precise communicators. So, in order to become a good prompt engineer, you need to be able to put your views, opinions, ideas, thoughts, whatever it is in your mind in a proper way or the most simplest way. Then only you can consider yourself as precise communicator. So, this is the second important thing that one should have. And the ability to reiterate, test, and evaluate our own instructions is the next important thing that tells us that we are a good prompt engineer. For example, whatever we say, if somebody is not able to understand us, then we are going to explain it in a better way, right? So, similar to that, if we are able to iterate, test, and evaluate the instructions that we give to the LLMs, then we can call ourselves as eligible to be a good prompt engineer, right? I'm not saying directly a good prompt engineer because it takes a lot in the background to be a good prompt engineer. So, the ability to iterate, test, evaluate the instructions that we give to the AI agents or LLMs in the background, this counts towards improving the prompts. Those who improve the prompts technically are called as good prompt engineers, right? So this is going to be next level skill set, trust me, because every single workplace is going to adopt AI systems. In that case, There should be someone to communicate our instructions with the AI systems, so that the people who interact with AI systems might not have proper set of instructions. So there should be someone between the users and the AI systems, so that they improve the understanding capabilities of these AI systems by instructing them in a particular way, so that they will understand the normal instructions better, right? So this is going to be next thing that we mention as part of being a good prompt engineer. Finally, we have this creativity and control balance. For example, uh, if we are given a chance to work on a particular thing, let's say the art, we show all of our creativity there. We put all of our creativity on the paper, right? But if we are controlled in a way that it communicates a better message, so that the art is not creative anymore, it's all about it speaks a lot, right? If we put our creativity on a paper in terms of art, we design and show all of our creative skills. But if there are control measures while designing the art as well, in that case, art is not about the design, it communicates a lot, right? So similarly, rather than having a creativity in terms of maybe a lot of creativity, controlling the creativity is another aspect, so that the output, sometimes when creativity is used a lot, might be less efficient, and the output when creativity is controlled could be a better output. So what we have been watching here is balance between creativity and the control of the output is necessary here for efficient and quality outputs, right? So those who balance the creativity with the uh, control over the output, so they can be called as good prompt engineers, because sometimes we go to an extent where we instruct the LLMs or even the AI systems a lot. I would like to mention this a lot. We instruct the LLMs or even these so-called AI systems a lot, so that LLMs or these AI systems would hallucinate a lot because of this more information or more creative side of the information, so that they hallucinate a lot and they will give nonsense information, right? So in that case, what we need to have is, we need to have a balance between creativity and the output control, right? So with this, let's just dive into this agenda of today's video. And agenda follows like this: we are going to discuss how LLMs process prompts and anatomy of a prompt structure and prompt formats and patterns, live demo of prompts and the breakdowns or the failures while giving the prompts to this LLMs and AI agents. So there are a lot of scenarios where prompts fail. For example, if we give some instructions to these AI systems or the LLMs, we get frustrated sometimes, we get irritated sometimes. It is all because of these AI systems generate nonsense information, because it is because of the poor prompts or poor instructions that we give to these AI systems or LLMs. And second thing is, AI systems are much more capable of generating the hallucinated results, because LLMs have been trained on a lot of information, so that they don't have access to this particular context to which we are talking about. For example, if you are talking about your school, LLMs won't have access to the information that relates to your school. So, in that case, if you give poor instructions or simple information or simple instructions, LLMs go beyond the hallucination. They would give nonsense results, right? So, in that case, what we need to do is, we need to give better context, so that this LLM systems or these LLM systems would generate better results. Third thing is, irrelevant context. For example, if you are talking about the marketing scenario, while we are talking about the marketing scenario, we need to give a lot of information such that these AI systems understand a lot about our businesses, so that they give tailored responses particular to our businesses. So, if we do not give context which is relevant to our businesses and expect better results from these AI systems, it wouldn't work, because AI systems or these AI LLMs have got nothing or no information about your business, which refers to poor context or irrelevant context of your business. So, giving the context which is relevant to your business is far beyond the greatest skill that one could have while communicating with the LLMs. And we do a lot of mistakes while communicating with these LLMs. First thing is improper inputs. First and foremost thing that I have to mention here is improper inputs from the human side. For example, if you are communicating with the LLMs or the AI systems, we do not give proper input. Sometimes we miss out on the most important information that needs to be fed to the models or AI systems, so that they hallucinate a lot. They generate nonsense results, and sometimes they even go beyond the hallucination, and they will irritate humans. It is all because of the improper inputs, right? So, what happens when you submit a prompt? Because everybody is saying we need to give proper prompts, we need to learn prompt engineering. But what happens in the background when you submit a prompt? So, the first and foremost thing that happens when you submit a prompt is tokenization. Prompt is nothing but a sequence of words, right? So in that case, every single sentence or every single prompt is divided into group of words, or even a single word, or let's say the sequence of single words. In that case, tokenization is performed to break the entire sentence into parts. Later, positional encoding has been carried out to encode the sequence of characters, sequence of words into particular sequence of, let's say, the entire sequence of words have to be represented in particular format. So that refers to positional encoding. It is most important concept, because if we alter the positions of the words in a particular sentence, the entire meaning of the entire sentence will be changed. For that, what we need is we need to encode the positions of the words within a sentence. This is what positional encoding refers to. Later, we have the attention applied to tokens, because out of all the words within a sentence, not every word is important within a sentence, because a sentence might contain a lot of words. For example, uh, if I say write a poem in 5 to 6 lines with rhyming included in it. So within this sentence, this sentence or this prompt might include 10 words, but not every single word is important for the LLM to generate the text. In that case, it needs to focus on particular tokens or particular words, so that it can generate the most relevant output related to the input, right? So in order to focus on the particular words within a the entire sentence or the prompt, it needs to have attention mechanism, so that the less attentive or less important words will be ignored, and the most important words will be focused much, right? So this is the next thing. Attention mechanism have been applied to the transformers are nothing but the earliest advancement to the LLMs. They're nothing but they're like the fathers of, or father of LLMs. Let's say, when we refer to the father of LLMs, it's more of like a human who has invented the LLMs. But when we say father of LLMs, or the ancestor of LLMs, let's say ancestor of LLMs, so that they refer to the previous advancement to the LLMs, a one step earlier advancement to the LLMs. So these transformers work on basis of attention mechanism. So attention mechanism is kind of a boom within the research, so that they have worked on the attention mechanisms iteratively, and LLMs have emerged over the period of time, right? So later we have the generates the next token. The thing is, when you submit the prompt, first thing is it performs the tokenization. Second thing is positional encoding. Third thing is applies the attention mechanism to the tokens. Based on the attention, the attention factor, it generates the next token, right? So this is how the prompt has been broken down in the background, so that it will be processed in a sequential manner. Finally it generates the next token, which is nothing but the predicting the next token. So to have a good view at this process, when you give the input text, the tokenization is performed and the neural processing is done, because transformers are nothing but the neural architecture, complex neural architecture. So whenever we give inputs to these transformers, they process the input in particular way, where all the inputs or the words goes through the neural processing. And then once the input text is processed, these neural or new neural networks uh, generates or predicts the next word in the sequence. So this is how, once the word is generated, it is going to be predicted in the next neuron in such a way that, based on the attention mechanism itself, the attention factor of the word, based on the attention factor and the attention mechanism, these neurons are generating the next word or predicting the next word in the sequence. So that's how output is being formed finally. So, in order to understand how tokenization works, first thing that happens is, whenever we give the text, it is considered as an input, and then input text is divided into or separated into tokens, so that these tokens are nothing but the individual words or group of words. And these tokens are converted into embeddings, so that these embeddings are finally represented in the vector form. For example, embeddings are nothing but the vector form of the tokens. Let's say, how do you think, or what is the process that you think, what is the process that you think is going to be implemented in the background for comparing the similarity of the text? For example, if I ask about particular information about the tourist places, it is going to exactly match the tourist information which is in the database, because LLMs have been trained over the period of time with a particular database. So LLMs are going to generate the next word or predict the next word from the information that it has, right? But the thing is, everybody misses out on this concept called information retrieval. LLMs are going to retrieve the information from the large amounts of data that it has been trained, so that the information that it has retrieved works as the context while generating the answer to the given query or input, right? So we give some input, right? So based on the input, it needs to generate the massive amounts of text. But how can we trust this generated input or generated output, right? So for that question, engineers have come up with some amazing answer called information retrieval. LLMs have been trained on massive amounts of data, so that whenever they generate some text, they search for relevant information from its database, and then this relevant information works as context to the text generation, right? But information retrieval happens only with the comparison, because if you are not comparing things, how can you say that the relevant, the retrieved information is relevant to the input that we have given, right? So in that case, there should be some comparison technique that is happening in the background while retrieving the information from the database. That comparison technique happens only when the data is in mathematical form, or vector form. So, vector representation of the information that we give is nothing but the embeddings, right? So, the input that we give is broken down into tokens, and those tokens are converted into embeddings so that LLMs use, or the algorithms use these embeddings to compare with the existing information from the database, right? So that's how information retrieval happens in the background. Once the information is retrieved, it serves as the context, so that while summarizing the text, entire text, next word is predicted in the sequence, so that entire information is summarized in a particular way, where um, summarization happens based on the predicting the next word, right? So with this, first process, or the first step in the entire process, is nothing but the tokenization, and we have seen enough about this. And the next step is positional encoding and context windows. For example, in the entire prompt that we give to these LLMs, the prompt is broken down into tokens. And if we do not give the positional encoding, or if we do not perform the positional encoding, or if we do not um, categorize the context of the entire information that we have broken down. For example, if I say write a poem in 5 to 6 lines with rhyming included in it, then it is going to break this entire sentence into three parts. First part is write a poem, and second part is 5 to 6 lines. Third part is rhyming included. So for every position, if I change the position, rhyming included, and 5 to 6 lines, maybe if I just reverse this entire sentence, it forms like rhyming included, 5 to 6 lines, write a poem, which misses out on particular context, right? So positional encoding helps us preserve the context. So in that case, the order of the sentence or order of the information matters a lot here, because if the order is changed, the context of the entire information or the input that we give to the LLMs or the AI systems changes a lot, right? So that's why if somebody is not communicating with you in a proper order, then you feel like some, confusion, right? Similarly, if the order is not preserved, then the LLMs or AI systems are going to hallucinate a lot, because what they understand from the misordered information is completely different from the original context, right? So, context window limit, in the sense, the next important factor that we need to consider while this positional encoding refers to is, because not every LLM is capable of processing huge amounts of text, right? Because if you type in ChatGPT 4o, particularly the model I am referring to here is 4o. 4o is capable of taking a long form of input, and it is capable of generating long form of output. So these models over the period of time have been improved to accept a long context, right? So that's where, while these AI models are capable of accepting a long form of input, we are experiencing the amazing outputs of the thinking and reasoning capabilities of AI models, right? So context window limit have been a important constraint while giving input to the LLMs. Because if an LLM is able to understand a long form of context, we can say this LLM could perform better in real time scenarios. So, in that case, context windows limit refers to breaking down of the information when we give a long context to the LLMs. If we simply type in a simple sentence, it doesn't matter. If we give a long information to the LLMs, based on the context window limit, the information that we give gets broken down into chunks, so that the most important information might be ignored in the next part. The only first part might be considered. So, in that case, what we can say is the most important information is retained in the second part, while LLM considers only the first part due to its context window limit, right? So first thing is the order of the information that we give matters a lot to preserve the context. And second thing is the context window limit of the LLMs matters a lot because while we give a long form of context, based on the context window limit, it gets broken down into different parts, and maybe the first part only will be considered while LLMs generate the text, which is going to ignore the context, and then it is going to generate a lot of irrelevant data which frustrates the human, right? And the third thing is what happens when context exceeds limit. So we have been seeing this amazing capabilities of ChatGPT to remember the text. For example, if you open a new conversation and if you type or if you converse or if you chat with the ChatGPT for a long time, it is going to retain the entire context within the conversation. It is all capable of the context windows limit have been increased to the next level. It could be 128K, it could be 256K, it could be 1 million input, 1 million token input, right? For example, if your model is capable of taking the 1 million token input, then we can say that model performs better with the long context. If a model is taking just the 128K tokens, then we can say that model misses out on the context when we give the long context, right? Long information. So it depends on the model to model. While generating the input, while generating the output, it considered or we need to consider the context limits. If a model is capable of taking the long form of input, then we can say it preserves the context over the period of time in order to generate the relevant text, right? So that's why context limit matters a lot while giving the information or the context to the AI models. So with this, we need to understand that positional encoding and context windows matters a lot while giving the inputs to the AI systems here, right? Later, we'll come to this amazing concept called attention and prompt length trade-offs, because we've been discussing about the attention mechanism. It's all about giving the attention to the important words that are much needed in the entire. We give prompt with a lot of instructions, right? But giving attention to specific terms within the prompt is necessary in order to generate or in order for LLM to understand the relevant context and generate the relevant information. So if we give some nonsense in the input, still, if it considers the nonsense, it is going to be misinterpreted. The information is going to be misinterpreted by the LLM, and then it generates some nonsense text. So, in order to avoid that, what we are using here is the attention mechanism, so that LLM focuses on the much important words based on the attention factor, so that it generates the information that is relevant to the important words that we have given, right? So, and in order to look into this better, let's have a quick look at the longer few factors, out of which longer prompt is nothing but the dilution of attention. If we give a lot of information to a child, does he understand? No, right? He gets confused. Similar to that, if we give a lot of information to the LLMs, the most important information gets diluted, and the attention of the LLMs is diverted, and then it generates the information which is irrelevant to the context that we have given. We know a lot of things. We want to communicate a lot of things with the LLM, but the thing is, LLMs require only the input that is very much needed. For example, let's say if we want to talk about a particular thing, we need to focus on that thing only rather than giving a lot of information. So when we focus on the particular thing, LLMs also focus on that thing itself and then generates relevant information where we have specified things or specified input within limited text. So there are two things: giving the limited text as well as giving the precise text or precise input. Giving the limited input or giving the precise input. If we give the limited input, LLMs would generate irrelevant information. At the same time, if we give the longer input, LLMs would get confused and would generate a lot of information which could be irrelevant to the query or the input that we have given, which could be confusing or nonsense to the query that we have given. So in that case, we need to give precise inputs or precise prompts. Precise inputs refers to the the good attention of the information. Longer inputs or the longer prompts refers to the dilution of the attention. So second thing we have as part of the attention and the prompt length trade-offs is nothing but prompt optimization. So prioritizing the important info early um, preserves the prompt context. For example, if we give the most important information in the first part of the prompt, even when the prompt length or the context limits cuts the information, the most important information will be preserved in the first part so that LLM considers the first part by ignoring the second part. So, prioritizing the most important info in the first part of the prompt would help us or would help LLMs to preserve the context in the first part and generate the relevant information even when the context limit exceeds. Right? So, that's the next important thing one should have as part of the skill set. Optimizing the prompts comes from the prompt engineering itself. So, prioritizing the most important info in the early part of the prompt um, boosts the prompt's output so that the prompt's output will be optimized, or let's say the LLM's output will be optimized from the prompt optimization. Prompt optimization is nothing but giving the most important info in the first part of the prompt. So with that, what if we can give this creativity to this prompt itself? Within the prompt itself, if we can give the creativity or if we can add creativity to the LLMs and all, how would it look like? Right? Till now, we have seen the attention mechanism, but if we add some creativity to the attention mechanism, how would it look like? Because if we give attention to the information that, for example, if we add attention to the specific information within prompt, it is going to focus on that particular information. So in that case, what if LLM is creative enough on focusing on particular information within the entire prompt that we give? So what if LLMs get creative while focusing on the important information in the entire prompt or entire information that we give? So that's where we come to this concept called temperature. Temperature indicates the creative aspect of the LLMs. So more temperature, it means more creative. Or let's say more temperature means it is less creative, and less temperature means it is more creative. For example, if we give more temperature, it refers to LLM's strict capabilities of focusing on the context, which means it is bound to the context. It is not able to go beyond the context. If creativity is less, it performs very strictly so that it is bound to the relevant context. If creativity is more, it is bound to the creative aspect rather than the context aspect. So then it shows its own creativity, and it generates a long form of context with lengthy information, right? So temperature refers to the randomness. If we increase the temperature, it increases the randomness, so it increases the creativity. If we decrease the temperature, it decreases the randomness, which means LLM is bound to the context rather than the creative side. So in that case, LLMs would perform strictly binding to the context rather than their creativity, right? And then later we have the top K, which restricts the vocabulary, right? So if we mention top k, then it restricts its vocabulary rather than generating the lot of information. For example, if we mention the top k, in the sense, while it retrieves the information from the database, it focuses on the only on the top k sentences. So which means it is restricting its vocabulary. It is all about restricting the LLM's vocabulary. When we restrict the LLM on vocabulary part, it is not going to generate the creative information. So in that case, it is bound to the context particularly. Later we have the top P, which means nucleus sampling, which refers to getting the most positive or most relevant information from the top K, right? So top K is nothing but top K refers to restrict vocabulary, which is nothing but restricting the creative side of the generating text, which means if we increase the creativity, it is going to show its creativity in terms of vocabulary. If we restrict it, it is going to explain the things in a more simplest way. And top P is nothing but nucleus sampling. Nucleus sampling refers to an atomic anatomy where nucleus is the most concentrated information with all the protons and electrons surrounded by it. Similar to that, getting the most relevant information from the retrieved information refers to top P, right? So with this, we have another thing, comparing the output fly. We will leave this option to you itself. Maybe just experiment with AI models, and then we're going to see this option as well in next videos. But the thing is, experiment on yourself and tell us in the comment section. We are waiting for your outputs, and we are waiting for your results from the experiments. We would love to see those results in the comment section, right? And then we have this prompt truncation and unexpected failures, because not every prompt is perfect, not every instruction is perfect. Sometimes, based on the model's capabilities, input might get truncated, and sometimes LLMs will give some unexpected failures as well. It's all because of the limited capabilities of understanding of these LLMs, or even the prompt truncation, because it's all because of the prompt limit or context limit. If the context is limited to particular number of input or particular number of tokens, then these LLMs wouldn't consider the information which is beyond the prompts or which is beyond the context limit. In that case, prompts get truncated, which means truncates at token limit, which refers to the context limit. If the context limit is 500 words, if I give more than 500 words, it is going to be truncated. Only the first 500 words will be considered, and if the most important information is retained in the next part, then the LLMs is going to lose the context. In that case, while the prompt or the information truncates at a particular token limit, the information is lost in the next part, so that LLMs wouldn't have information or relevant context, so that they would generate some irrelevant information. Outputs may end mid sentence, because based on the context limit is in terms of input as well as the output as well. So while considering the input, the context gets truncated so that it would generate some nonsense information. At the same time, while there is limit on the output generation, they would generate a lot of information, but the thing is, it would get truncated in the middle of the entire information, where we are facing this improper information or incomplete information from these LLMs. It's all because of this limit on the outputs of the LLMs, because sometimes outputs of the LLMs are limited to 500 words. I mean, it's not real in real time, but the thing is, sometimes LLMs are limited to generate 128K of words, or even LLMs are limited to generate maybe 100K words, right? So in such scenarios, Outputs get truncated based on the context limit as well as the output limit. And the third thing is the most important thing while we refer to the prompt truncation or context limitation, we need to understand that token discipline is the most important thing here. If we specify the most important information in the first part or first uh, few words itself, it is going to preserve the context. So having the discipline of token usage is nothing but referring to giving the most important information within the first part or first few lines itself is known as token discipline, right? Which improves the which improves the outputs from the LLMs in a better way while giving the context in the first um, few lines of information itself, right? So let's understand the anatomy of the prompt and we'll wrap up this video. And this prompt anatomy comes with some amazing components. Uh, if we are giving prompts to particular LLMs or AI agents, we need to have at least four of these components within our prompt. First thing is context, provide some background or context for the action. Who is the audience? What tone do you want to set? For example, if you are expecting the output from the LLM in a professional manner, you need to mention that in the tone of the output, right? So you need to give some background of the information that you want so that it understands better and generates the information that is relevant to the background that you have mentioned. Second thing is you need to give AI systems a particular role in order to act in a proper way. Because if I am asking information related to some kind of medicine or something like that, you need to tell the AI systems to act as a doctor or to act at least as a practitioner. That's what giving role means. For example, if I am asking ChatGPT to design a plan or study plan to learn AI agents or to learn agentic AI, at the time of giving this prompt, I need to mention its role as a expert AI engineer guiding me in learning this agentic AI, right? So role plays a key factor. Role acts as a key factor while giving the inputs to the ChatGPT or whatever the AI systems in the market, right? And then we need to specify the action it needs to do, because if you are asking a question, it needs to answer the question. If you are searching for information, it needs to provide the information. If you want ChatGPT to summarize the things, you need to mention it in the prompt. If you want ChatGPT to revise the information and keep the information in simple terms, you need to mention that. So giving the action as a third step is the most important thing here, the most important component of the entire prompt. Because if you don't instruct the AI systems on what they have to do, they're going to lose the information of what it has to do, and then they're going to generate some random text, right? If AI system is expected to generate the information related to some kind of let's say AI technology or experiments, research and all, it needs to generate or it needs to perform an action that generates the text relevant to the particular theme, right? So if we do not give particular action, then it is going to hallucinate and it is going to perform its own action. And finally, you need to describe the expected output here. If you are expecting the output in a JSON format, if you are expecting the output in a paragraph format, if you are expecting the output in bullet format or Excel sheet, whatever it is, the structured format, whatever it is, you need to mention it, because without mentioning it, it would generate simply paragraphs, right? Because by default, text generation is in paragraphs only. So if you have a look at this example, which we have given to this chat GPT, I am applying for a position at a company. This is my second interview. I'm giving the context here. And second thing is act like a interviewer and a hiring manager. This is giving a role information to the chat GPT. And third thing is we have the action, which is nothing but analyze the following job description and tell me what questions I can expect in an interview. So where we are preparing for an interview, we are asking the chat GPT to guide us in terms of questions and answers that we need to give in an interview, right? And we are expecting the bulleted information from the chat GPT. So this is how we need to give it. This is very basic these days. First thing is we need to provide the context like we did in the example. And second thing is we need to give ChatGPT a particular role like we did in the example. If you see, I'm asking it to act like an interviewer and a hiring manager. Third thing is we need to give the actions that it needs to perform, like analyze this text or analyze this job description, analyze the resume, analyze this textbook, analyze this document or something like that. Finally, we need to specify the output format in order to avoid the irritation caused by the AI systems. So this is a very basic thing because part of the prompt itself, everybody these days who are communicating with the AI systems need to have this basic understanding of prompt engineering, how prompt engineering works and all, understanding of the prompt, sample prompt, anatomy and all. So with this, you can write effective prompts, right, while communicating with the AI systems. So there is a lot more in terms of prompt techniques, prompting strategies, prompt methods, or prompt styles, prompt templates. Everything is planned in next videos. So stay tuned to us. With this, we come to an end of this video of prompt engineering foundations, how LLMs interpret the prompts, and what are the constraints or what are the problems that are faced while giving prompts to the LLMs or giving instructions to the LLMs. We have seen everything in this video, and we're going to see how to give or how to write effective prompts in the next video. We're going to have prompting techniques, prompting methods, prompt structures, how we give prompts when we use different frameworks and different libraries and all. So stay tuned to Data Valley's channel, English channel, and we're going to come up with some amazing content in near future. Everything is lined up, so stay tuned to us. With this, signing off, Sai Harsha Konduiti from Data Valley's AI Center of Excellence. Thank you all. Thanks for watching.